This is the Smart Pipeline Monitoring Robot, created by Hamdan and Naufal. The robot's function is to detect corrosion that happens within pipelines. The corrosion is of two types: sweet corrosion, which is also known as the silent killer, which is caused by CO2 and H2S gases, and environmental erosion, which are the regular cracks and dents in the pipeline caused by external stimuli. The robot is broken down into three main parts, which starts with the electronics, done by Naufal, where he has wired up the machine with over 14 sensors, including sensors to detect the silent killing gases, sensors to detect CMG, methane, altitude, humidity, pressure, and many more.
Hello everybody, my name is Naufal and I did the electronics part. And if you see, as the brother told, the electronics part has a couple of sensors, like almost 14 sensors connected to it. And the most important vital which we are trying to recognize and capture are the gases, the concentration of each gas inside the pipeline. So we have divided this into two. Number one is the gases in the positive side, in the sense the gases which are good for the pipeline, the gases which travel inside the pipeline, like CNG, methane, and all of them. And in the negative side, in the opposite end of the spectrum, lies the gases which uh, cause what do you call corrosion or sweet corrosion, as the brother told, in the pipelines. So we have a couple of sensors to detect each, and mainly we have three sensors which detect each and every one of these gases. So mainly uh, CNG, methane, carbon dioxide, carbon monoxide, and mainly the H2S gas are detected. So moving on, we also have some barometric pressure sensors which detect the altitude, pressure, and also we have some humidity and temperature sensors to determine and to get a feel of everything which is inside the pipeline.
The second main part of the robot is the mechanical part of the robot that deals with motion. This was done by Hamdan, where he started with a 3D model of the robot, which he then made into a reality using stainless steel for its structural integrity and giving it a matte finish. Hamdan then attached the wheels which move the robot through the pipeline, attaching springs to them so that they can adapt to the insides of the pipeline.
The entire body is made up of stainless steel and which are welded up together, and there are about 6 arms which are attached with springs which help in the adjustment of the arms so that the arms can be fit according to the width of the pipeline.
Lastly is the AI, which is done by Naufal. He was able to program and teach an AI to detect cracks in the pipeline and chart them using two main features of the robot. One, the front-mounted camera.
And we train the AI in two ways. One way is with OpenCV, which is used for real-time detection. And the second way is what takes a lot of space and a lot of computing power, and this one is done in the cloud. We have trained an AI model with 20,000 labeled images of cracks and non-cracks, which are used to detect each and every crack in the pipeline. As you see there, these are some of the images from the dataset we used.
Secondly, the radar mounted in the front of the robot, which rotates and takes 8,000 samples a second. The AI then takes this information and plots it on a point cloud, which shows peaks or throws on a graph, which indicate a crack in the pipeline. The theme of this project is to create solutions and make ways to easily access places which are normally inaccessible and hazardous for humans.